Okay, flyers, here we go. Today we're going to do solving linear inequalities. So those are lines that are not equal, so that they're either greater than, less than, greater than or equal to, or less than or equal to. So the first thing we're going to do to refresh our memory on how to graph these inequalities. So on number 1, we have x is greater than 3. That means we want all values bigger than 3 but not equal to it. So we're going to put an open circle on 3, which means we don't want 3 itself but everything right up to it. So we want 3 and bigger. X is greater than 3. Number 2, we want x is less than or equal to negative 1. So we're going to put a closed circle here on negative 1 because x can be less than or equal to negative 1. So we want to include negative 1 in our set. And we're going to shade to the left where the less than values are. Those are all the values less than negative 1. Number 3, sometimes it can be confusing when they're written backwards. So if we read this left to right, this is 2 is less than x. But that's sometimes hard to wrap your brain around. So you can either read it from right to left, which would be x is greater than 2. Or if it's too difficult to read from right to left, you can just flip the whole thing around. So x is greater than 2. Either any way you think about it is fine, as long as you think about it correctly. So it's an open circle because it's not or equal to like it was on number 2, and we want greater than, so we are shading to the right. Okay, let's do some solving. So on number 4, we're going to solve and pretend that it's an equal sign. We're going to proceed just like it's an equal sign. So we're going to add 4 to both sides, and we get 3x greater than or equal to 15, and we're going to divide by 3, divide by 3. So x is greater than or equal to 5. Okay, and if we throw that on a number line so we can see the numbers that we're talking about, we can just put in some surrounding values, 4, 5, 6, and we're going to say we want 5 itself, so a closed circle on 5 because it's or equal to, and we want all the values bigger than that, so 5 and above. On number 5, again, we're going to proceed as if this were an equal sign. We're going to subtract 7x, subtract 7x, so we get our x's on the left, and we get negative 2x plus 2 greater than negative 4. Now we're going to subtract this 2 from both sides, so we have negative 2x greater than negative 6. Need to get this x by itself, so we're going to divide by negative 2, divide by negative 2, and at this point, this is our one rule that makes inequalities different than equations. This is what makes the less than or greater than signs different than an equal sign, and that is when you are dividing by a negative or multiplying by a negative, you must flip the sign. So we're going to write this down here. When you multiply or divide by a negative, when you multiply or divide by a negative, you must flip the sign. Okay, so that's our only big rule when we're dealing with inequalities. So we're going to divide by negative 2, which leaves us with x is less than, because we flipped the sign, positive 3. So if we make our number line again, we've got 2, 3, 4. We are going to say everything from 3 and below, not including 3. So it's an open circle on 3. Number 6. These are called compound inequalities. Number 6 is called an and inequality because there's 2 pieces here. We've got the left side, which you can think of as this inequality, okay, or the right side, which would be this inequality, but we put it into one large inequality, which is why it is called a compound inequality. So when we do these, it's really important that your focus is right here in the middle. Your job is to get x by itself in the middle, so we focus right there. So to get x by itself here in the middle, we're going to add 5, and we need to add it over here to the right, and we also need to add it over here to the left. Because we're combining two inequalities together, we actually have 3 different sides to the inequality. So now we have -3 less than or equal to -x less than 6. Again, we are focusing on the middle. Our job is to get x by itself in the middle. And so here we're going to divide by -1, divide by -1, divide by -1, all 3 spots. Now remember our rule, when you multiply or divide by a negative, you must flip the sign. So we need to flip all the signs. So this will be a greater than or equal to, and this will be a greater than. So we've got -3 divided by -1, we have +3, we have x in the middle, and we have -6 on the right. What does that mean? If we just look at the left side here and we read it correctly, this is x is less than or equal to 3, so x is smaller than 3. If we look at that on a number line, we want x smaller than 3, so less than or equal to 3, so we're thinking we're shading this direction. But also x must be greater than -6. So over here, somewhere out here, we've got -6. 5, 4, 3, 2, 1, 0, 1, 2, 3. So there's our number line. We want x bigger than -6, so we want an open circle on -6, and we want bigger than that, so we are shading to the right. And where do these two overlap? Well, they overlap right in between. Okay, so if you need this in words, we're going to say that x is greater than -6. So this is bigger than -6 and less than or equal to, less than or equal to 3. So it's in between -6 and 3. So that's a compound inequality, that's an and inequality, that's when they're smushed together. Number 7, this is an or inequality. These are much simpler because it's just 2 side-by-side inequalities. So we're just going to solve them separately. So we're going to add 4 to both sides. -x greater than or equal to 5, divide by -1. What do you do when you multiply or divide by a negative? You flip the sign. So we're going to flip the sign, so we have +x less than -5. So if we do the same over here, we're going to subtract 2 from both sides. We get -5x less than -10. We're going to divide by -5. When you divide by a negative, you must flip the sign. So we have x is greater than 2. And this is an or problem. If we go back up and box our answers, there's our and problem. This is an or problem. So if we check this out on a graph, we're going to have -5, -4, -3, -2, -1, 0, 1, 2, 3. So we want x is, oh, I forgot my or equal to sign over here. So x is less than or equal to -5. So it's -5 and below. Everything below -5. Or x could also be 2 and above, greater than 2. So that's why this is an or problem. We have 2 different pieces. X could be over here, less than or equal to -5, or it could be over here to the right, greater than 2. Whereas on number 6, x had to be both things. It had to be both greater than -6 and less than -3. So number 6 is an and inequality, and number 7 is an or inequality. Okay, here are your video examples. You have 4 problems. So go ahead and pause now or stop now, write down these 4 problems, and we will go over them tomorrow. See you tomorrow.